In this last lesson of the chapter, we'll be solving quadratic inequalities. And you'll see some steps here for solving this. What you'll do is you'll solve the related equation. So notice these will have inequality signs, greater than or less than or equal to. But what we're going to do is solve the related equation. So we're actually going to make it an equal sign. We'll solve it. We should get either 0, 1, or 2 answers, or zeros. We'll put them on a number line. And when you put the points on a number line, it will be split into different intervals. And what we'll do is we'll plug a point from each interval into the inequality, so back into the original. If it makes the inequality true, then all points in that interval work. And if it makes the inequality false, then nothing in that interval works. And then we're going to write our answer as an inequality. So we'll just jump right into it. We're going to solve this related equation. So we're just going to write x squared minus x minus 2 minus 2 equals 0. And we can solve by factoring or completing the square. In this case, it looks like we can factor. So we will factor. That's the easiest way to solve if it works. How do we get an x squared? We have an x and x. And then it looks like we'll have a minus 2 and a plus 1. So that factors to that. And so our answer for this equation is x equals 2 or negative 1. So we did solve the related equation. So now we're going to make a number line. It doesn't have to be real detailed. We have negative 1, 0 somewhere around here, and here's 2. And so here's our main zeros that we're thinking of or working with. And now what we want to do is we want to plug a point from each interval. So let's say interval 1. Let's see, where do we want to do this? Interval 1. Our first interval is going to be to the left of negative 1. So we have left of negative 1, in between negative 1 and 2, and then to the right. And so let's just pick up a number down there. Let's try negative 4. So we'll put a negative 4 into our original in this case. So we got negative 4 squared minus negative 4 minus 2. And we want to know, is that greater than 0? Well, we have 16 plus 4 minus 2. We actually don't even need to go down and solve it all the way, although we can. It's going to be 20 minus 2 is 18. And we check, is 18 greater than 0? It is. That means everything in this interval works. Now, does negative 1 work? We come back here to our sign. It does not have the or equal to. So everything down here works. We'll try the second interval. Whenever we can plug in 0, whatever 0 falls in, that's easy to use. So we would do 0 squared. Again, we're putting it back into this one. Minus 0, minus 2 is greater than 0. This would be negative 2 is greater than 0. Is that true? Well, no, it's not true. Negative 2 is not greater than 0, so that section doesn't work. And then our third interval is things to the right of 2. Let's try 4. So we'll have 4 squared, putting it back into our inequality. 4 squared minus 4 minus 2 is greater than 0. 16 minus 6. So 10 is greater than 0. That's a true statement. And so this interval is true. And then we want to finish by writing this as an inequality. We have our inequality going in different directions. So this has to be an or inequality. So we can say x is less than negative 1 or x is greater than 2. And that is our answer. In this next example, we're going to do the same idea. So we have 2x squared minus 2 is less than or equal to 1 minus 5x. In order to solve something like this, we want to get everything to one side and see if we can factor. So we'll add 5x to both sides. And subtract 1 from both sides. That gives us 2x squared plus 5x minus 3 is less than or equal to 0. And we want to try to factor. If it doesn't factor, we would try using quadratic formula. So let's try factoring. We have a 2x and an x. And then it looks like we might be able to do a plus 3 and a minus 1. Might have to do a couple guessing checks, but I think this is right. And in fact, I'm sorry, I should have gone back. We want to solve the related equation. So up here, you really can do all this factoring with the less than and equal to. So now we can kind of think we're going to solve this equation. Oops, still put less than or equal to. And to solve this, either 2x minus 1 equals 0, or x equals negative 3 from this one. That's an easy one. Add 1 and then divide by 2. So x will be 1/2. Sorry, add 1 and divide by 2. So x equals 1/2. And now we'll put this on a number line. We have our two solutions that we got. We got negative 3 and then 1/2. And we would check our different intervals. We have an interval to the left of negative 3, an interval between negative 3 and 1/2, and an interval to the right of 1/2. So let's try negative 5. And what we're going to do is we're going to put that in this one right here. So we have 2 times negative 5 squared plus 5 times negative 5 minus 3 is less than or equal to 0. We're checking if this is correct. So this is our first interval, or interval 1. This is 25 times 2 is 50 minus 25 minus 3. That's going to be 22, and 22 is not less than or equal to 0. So this does not work, so we're not going to highlight in there. Now we're going to try our second interval. Our second interval, we're going to plug in 0. So we put 0 in here, 2 times 0 squared, plus 5 times 0, minus 3 is less than or equal to 0. Let's check that. These will be 0, so negative 3 is less than or equal to 0, which is true. So we're going to highlight in here. We're going to close this circle in because it's got the or equal to. And then we're going to try something larger than 1/2 for our third interval. And let's just try 1. So we have 2 times 1 squared plus 5 times 1, putting it into this inequality, minus 3. Is that less than or equal to 0? Well, this is 2 plus 5 minus 3. So that is 7 minus 3 is 4. 4 is not less than or equal to 0, so it doesn't work. So our answer is this solution right here, and we can write this as an inequality. So this is an and, but when it's something between two numbers like this, we can put the left number, negative 3, is less than or equal to our variable x, which is less than or equal to 1/2. And that is the solution, or those are the solutions for this inequality here. We'll go ahead and look at this third example. We want to solve a related equation. It's already set up in a nice form where it's set equal to 0. So we would try to think through factoring. And we won't be able to factor, so we're going to have to use the quadratic formula to solve the related equation. So I'm going to write the related equation. So equals 0, and we're going to use the quadratic formula. So x equals negative b, so b is 2, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4, times a, which is 1, times c, which is negative 5. All over 2a. And a is 1, so all over 2. And so we have negative 2 plus or minus, this is going to be 4 plus 20, so square root of 24, all over 2. We want to simplify the square root of 24. 24 is, once you factor it, it's 2 cubed times 3. And we can simplify that. So we got a 2 squared times a 2 times a 3. And so we have 2 root 6. So x equals -2 plus or minus 2 root 6. And we notice all over 2, we notice we have a 2 in all 3 terms here, so we can reduce by 2. This will be a -1, this will be a 1. And so we have x equals -1 plus or minus root 6. Now we want to put this on a number line, so we're going to get an approximate value for the square root of 6, which is about 2.45. So we got -1 plus or minus about 2.45. And so we have two answers here. We have -1 plus 2.45, which would give us 1.45. And then we have -1 minus 2.45, which would be -3.45. And so those are the two numbers we can put on a number line. We got the -3.45 and 1.45. And what we want to do, it's a 4. We want to check our different intervals. So our first interval will be to the left of -3.45. Let's just say -4. So put -4 in there. That's -4 squared plus 2 times 4 minus 5. And we want to check, is that greater than or equal to 0? So again, what we're doing is we're plugging these points into each interval, or of each interval, into this inequality. So we're putting in there, this is going to be 16 plus 8 minus 5. That definitely is greater than 0. So we know that's going to work. So this section down here will work. We'll try in between. 0 falls in this interval. Doesn't always fall in the second interval, but it has so far for us. So we're going to try 0. So our interval 2. 0's in there, so we'll do 0 squared plus 2 times 0 minus 5. It's basically saying -5 is greater than 0, which is not true. So we won't shade that section, and we'll check interval 3. And we'll check somewhere to the right of 1.45. Let's try 2. So we have 2 squared plus 2 times 2 minus 5. We want to check if that's greater than 0. And we have 4 plus 4 is 8 minus 5 is 3. 3 is greater than 0. So that's a check. And so this works over here. So we can write our answer as an inequality. This is going to be an OR. So we'll have x is less than or equal to, which I should have filled in my circles here because it's an or equal to. X is less than or equal to -3.45, or x is greater than or equal to 1.45. And so there's our answers. And our last one, we want to solve the related equation. First, let's put this, or get everything equal to 0. So we have x squared plus x. We'll be adding 3 to both sides, so plus 3 is less than 0. We cannot, again, factor this one, so we have to use quadratic formula. So x equals -1, because -b, plus or minus the square root of b squared, so 1 squared minus 4, times a, which is 1, and times c, which is 3, all over 2a. So this is all over 2 times 1. Simplifying, we have -1 plus or minus the square root. Well, this is going to be 1 minus 12, so -11. over 2, and we have a negative under our square root, so that we know that means we have an I. So negative 1 plus or minus the square root of 11I all over 2. And now what we want to do, we have two solutions here, and we would put this on our number line. Well, if we have a number line consists of all the real numbers. This is not a real number. So these numbers do not lie on the number line. Remember, when we graphed imaginary numbers, they would be either above or below the x or this real axis. So there's no numbers, none of our solutions are on the number line. We still actually need to plug in points from each interval into the original inequality. Well, the interval in this case is actually the whole thing. Like, there's no point in here to split it up into 2 intervals or 2 points to split up into 3. So our interval is actually the whole thing. So all we have to do is check one number. We might as well try 0. If 0 works, our answer will be all real numbers. If 0 doesn't work, we'll have no solution. So plugging in 0, so we'll put interval 1, even though there is only one interval. We'll plug in 0 into our inequality. 0 squared plus 0 plus 3 is less than 0. Well, we have 3 is less than 0 here. Is 3 less than 0? No, that's false. So since 0 didn't work, nothing in that interval will work, which means nothing will work, so our answer is no solution. No solution. Now I want to quickly relate this to something that we'll actually learn soon, and these answers that we get here. So, oops, when we graph, we'll learn to graph equations or functions like y is less than or equal to x squared minus 7x plus 2 or something like that. I'm not going to graph this one specifically, but the graph of a quadratic equation is a parabola. And when we have an inequality, we'll have to shade, just like when we shaded for a linear inequality. So the reason we get these, I'm just going to explain these answers here. So if we ended up shading in here, notice our answers, this relates back to the answers that we get. If something was shaded in here, everything on the number line here would be part of the solution. That's kind of like this example. So you can get answers where your solution is between two numbers. You could, in other situations, you could end up having to graph all out here. This would be like on our number line, what we're working with, this would be these being the solutions. So either on the left side of one number or on the right side of another number, like this one. The other situations that can happen is you could actually have one of these parabolas completely above the x-axis or completely below and shaded down here. Well, how much of the number line is shaded? The whole thing. So that would give you all real numbers. This would happen if you had an imaginary number and 0 did work, and then this one right here would be something kind of like this, where you would have the parabola here, but it would be shaded up here, and so it never crosses. So that's where these different solutions come from. So really, when you get answers, you actually have another situation where you have this parabola that hits the x-axis just at one point. So you could just get one solution or all the solutions. But so you often get between two numbers, like an and, an or, where you have two of the intervals work, but not the middle one. And then these two have to do with imaginary solutions. And that is it for solving quadratic inequalities.